As usual, I'd say watch part 1 first. This is going to make absolutely no sense if you haven't. We're going to look at some chain rule exam questions now. So lastly, I've stuck all of those rules on the side here, and if you're going to copy out anything, I think, from this, that would be the box to have. I put it somewhere important in your book, in your notes. We're going to look at a couple of exam questions that use this, and we're just going to see how we can do them. Again, you probably want to pause at each question, have a go, and then see if you match up to what I've got, but I'm just going to crack on. So for A, we've got e to the 3x and ln to the 2x. Now those are two separate terms, so we're going to differentiate them separately. Let's do e to the 3x first. So let's say if we just had e to the 3x, then we'd be saying, chain rule wise, y equals e to the power of u, and u equals 3x. If I differentiate them, I'm going to get myself e to the u again, and 3. So if I multiply those together, I'm going to get dy by dx is 3e to the u, which is 3e to the 3x. Okay, great. What about the second term? Well, I've got ln 2x. If I differentiate that, I'm going to say y is equal to ln u is equal to 2x. I'm going to say dy du is equal to 1 over u, and du dx is equal to 2. I'm going to multiply them together and say dy dx is 2 over u, which is 2 over 2x, or 1 over x. So that gives us our final answers. Our actual differentiation for the whole function, given we've got e to the 3x, is going to go to 3e to the 3x, which we got over here, and ln 2x is going to go to 1 over x. There we go. What about part B? This is a single chain rule, so we're going to go y equals u to the power of 3 over 2, and we're going to say that u equals 5 plus x squared. We've done ones like this already, so we can say dy du is equal to 3 over 2 u to the half, and u is equal to 5 goes away, so just 2x. Multiply them together, we'll get dy dx is 3 over 2 times 2 is just 3. So 3x u to the half, which is 3x, 5 plus x squared to the half, let's say, times the square root of, because that's the same thing. There we go. Now obviously we're going to want to try and bring in some other things, generally along the lines of normals, tangents, that sort of thing. Bit of log rules maybe. Let's have a look at how these deal with it. So we've got an equation here, y equals 4e to the 2x plus 1. We're told the y coordinate is 8 and to find the x coordinate. That's not really a differentiation question, that's just substituting and solving. So let's do that. We know y is 8 and we're trying to show or find what x is. So 4e to the 2x plus 1 equals 8. Divide by 4 would seem sensible to start with. And then we want to take natural logs of both sides because that would get rid of this and just leave us with 2x plus 1. And then if we want to get x on its own, we're going to have to subtract the 1. So ln 2 minus 1. And we're going to have to divide by 2. So x is ln 2 minus 1 all over 2. So there we go. That's our x coordinate of P. Now it says to find the equation of the tangent to the curve in this particular form, where we have to find those constants. It says exact constants, which doesn't mean integers, it means they could be anything, surds, roots, etc. If we want to find the equation of a tangent, we need to know two things. We need to know the gradient, and we need to know a coordinate. Now, the coordinate we've actually already found in part A. That's normally how these things work. We know that the y coordinate was 8, so our coordinate is ln 2 minus 1 over 2, comma 8. But the gradient we don't know, and the gradient is something where we have to find dy by dx. Now we've got our function as being y equals 4e to the 2x plus 1, so let's go chain rule. So in this case we've got y equals 4e to the u, and we've got u equals 2x plus 1. We go dy du is 4e to the u, and du dx is just 2. Multiply them together, so our dy dx is equal to 8e to the u, which is 8e to the 2x plus 1. Okay. Now, we have to substitute in an x value to that to get the actual gradient at that point. So let's do that. So we want to do 8e to the 2 lots of, and this is going to be the complicated bit, ln2 minus 1 over 2 plus 1. Now obviously you could just type this into a calculator and it would work out pretty well, but let's see if we can do this a little bit more mathematically. I would first, I think, cancel out the fact this is divided by 2 and times by 2, so that's just going to go away. And then if we look at it, that's going to give us minus 1 plus 1, so those will cancel out as well. And we actually end up with, a little bit nicer, 8e to the ln2. Now e to the ln2 is just 2, so this is 8 times 2. This is 16 for our gradient. So we've got our x1, y1, we've got our gradient. If we want to find a tangent, we can now sub that all in. So y minus y1, so y minus 8 equals m x minus x1, x minus ln2 minus 1 over 2. We can then expand that, so y minus 8 equals 16x, and then 16 divided by 2 is going to give us 8, so minus 8 lots of ln2 minus 1. And then we need to put it in this form, so it needs to be y equals. So how are we going to do that? So let's write it out a little bit bigger. So we've got y, we'll just add the 8 across, won't we? So y equals 16x, and then let's expand this bracket, minus 8 ln2 plus 8, and then plus another 8 from here. Tidy that up one last time. We've got 16x minus 8 ln2 plus 16. This is our value of a, 16. This is our value of b. Okay, let's have a look at a slightly more complicated one then. We've got y is equal to this horrible nonsense to the power of 3 over 2. We need to essentially substitute this x value into our dy dx. So let's go through. Our first thing is saying, well, y equals u to the power of 3 over 2, and u equals 1 plus e to the 2x. There's a little bit of a problem here in that e to the 2x isn't something that we know how to differentiate. Well, I know there are shortcuts we're coming to, but not just yet. We know how to differentiate e to the x. So we're actually going to use the old triple chain rule here, which works as follows. So I'm going to say y is u to 3 over 2. I'm going to say so, and u is 1 plus e to the, what's a letter I haven't used yet? Let's say to the w. And I'll say that w is equal to 2x. So you can sort of chain that backwards. If w is 2x, this is 1 plus e to the 2x. And if u is 1 plus e to the 2x, then this is the same as what we started with. And we're actually going to differentiate all three of these. So dy du times by the power, decrease the power. Du by dx, 1 goes away, so it's just e to the w, or du by dw rather. And dw by dx, that's 2. So we can multiply all of those together to get overall our dy by dx. So let's go through it. 3 over 2 and 2 are going to cancel out to just give us 3. So that's this bit sorted and this bit sorted. We've got e to the w and we've got u to the half. So let's substitute it in. It needs to look like it's in terms of x. So we've got 3e to the 2x. And u is 1 plus e to the 2x to the half. There we go. Not too bad. So apparently we need to substitute in that x equals a half ln 3. So let's do that. We want to do 3e to the 2 lots of a half ln 3 times 1 plus e to the 2 lots of a half ln 3 square rooted. Okay, well, good news is obviously that the 2's and the halves will cancel out. So we'll end up with 3 e to the ln 3 for our start term, and then 1 plus e to the ln 3 square rooted, to the power of a half, which is square rooting. E to the ln 3 is just 3, so we've got 3 times 3 there. We've got 1 plus 3 here, and that is, let's stop right in the half, that whole thing is square rooted. So we've got 9 times the square root of 4, which is 18. Okay, penultimate one. We've got, again, one of those sequences that have a couple of things in them. We've got y equals 3 sine 2x and 4 cos 2x. We can see that we're working in radians because the degrees are talked about in terms of pi, which might come into something. And we've got a point here, so this is our x1, y1. We want the equation to a normal. If we want to find the normal, then we want to do the negative reciprocal of the gradient. If we want the gradient, then we're going to have to find dy by dx. So let's do that. The first one we've got here, dy by dx. We are going to have to do this in 2 separate chunks. So let's say we've got y equals 3 sine 2x. So we're saying y is 3 sine u, where u equals 2x. And let's do the same thing we've done quite a few times now. So we've got cos u and 2, and we're going to multiply them together to get dy by dx is 6 cos u. And then we can do the same for the 4 cos 2x. So if we had y as 4 cos 2x, we'd be saying y is 4 cos u, and u is 2x. So that would differentiate to minus 4 sine u and 2. We multiply those two things together, and we get dy dx is minus 8 sine u. Put the u back in, that would be 6 cos 2x. That would be minus 8 sine 2x. Great. So we can say overall our dy by dx is those two things added up. That's our 6 cos 2x minus 8 sine 2x. And we want to find the gradient, so the gradient is where x equals 0. So we can sub in 0. That's going to give us 6 cos 0 minus 8 sine 0. Sine 0 is 0. Cos 0 is 1, so that's just going to give you a gradient of 6. Now, because we're doing the negative reciprocal, that means we need to flip that and make it negative, because we're finding a normal. So, let's actually find the equation of our normal. So y minus y1, y minus 4, again, they've given us the coordinate already, is equal to m, so minus 6th, x minus x1, so x minus 0. It doesn't say that it needs to be in any particular form, so I'll just expand this and add the 4 across, and that should do it. Minus the 6x plus 4. Okay, very last one. Again, we're finding the equation of a normal, so we're going to need to do minus 1 over m. We've got an x coordinate, but that probably means that we need to find a y coordinate. Here's the equation of our curve, so we want to differentiate that, and we want to put it in this form, so it needs to end up y equals. So let's go through. So our first thing would be to say that y is equal to ln of u, where u is equal to a third of x. We would differentiate them both. That would give us 1 over u, and du by dx would just be a third. We then multiply those two things together, so dy dx is 1 over 3u, and we can sub in that u is a third x, so that's 1 over 3 lots of a third x, which is 3 times a third is just 1, so 1 over x. Great. We then know our x coordinate of the point to the curve is 3, so we can sub in x over 3, and we can get that dy dx at that point is just equal to a third. But we want a normal to this, so our gradient that we're going to use is going to be minus 3, negative reciprocal of that third. We probably want to find a y coordinate as well. If we know that x equals 3, then y equals ln of a third times 3, which is ln of 1, which is 0. So we've got a coordinate 3, 0. We've got a gradient minus 3. So let's put that all together. Y minus y1, so y minus 0, equals mx minus x1. That 0 just goes away, so we've got y equals minus 3x plus 9. Okay,